Alright, so we're going to start looking at the quadratic function. This is we get deeper into this function than we probably do any other one this year. Okay. This warm up, this was just common terms that you will need to make sure that you are familiar with in this whole unit. So on the first one, quadratic function, which one is that? Which one? D. It can be written in this form right here, which is called the standard form. The parabola, which one was that? F. That's the shape of the graph. What is the vertex? I. Gavin, the axis of symmetry. What is it? Thank you, Gavin. Alessandra, the y-intercept. H. And the x-intercept. B. Good. Hopefully x-intercept and y-intercept are self-explanatory. Greta, the domain. No, not B. Alright, let's help us out. E. Jacob Wilson, the range.
It's J.
Dalton, the minimum point. And then the last one is G, last one I got. Alright, so some of those are probably common sense. Okay, there's others that you just need to know the definition of. Alright, so today what we're going to look at is the three forms of quadratics. So you can have three equations that look completely different from each other, but they result in the same parabola. They result in the same data. What I have highlighted up there already on D, this is one of those three forms. The reason we have three forms is you can get different pieces of information from different forms more easily than you can from others. So we're going to talk about those three forms. We're going to talk about what they look like, the information that you can get from it. And then at the very end, we're going to talk about how to take one form and change it to where it's in another form. So you should already have those equations cut out. So at the very top, you've got these three forms: standard, factored, and vertex. Okay? Those three forms, the reason why we have three of them, again, is we're going to get different pieces of information from different forms. What you need to know as far as identifying them is just know what they look like. Alright, is there a set of parentheses in standard form? No. Alright, if you go down to factored form, I got two sets of parentheses, neither one is being squared. I go to a vertex form, I have one set of parentheses and it's being squared. So you need to know just by looking at them, which form you're going to be looking at. On number 2, you're going to do this here in just a second. Going down to this bullet list, these are the different pieces of information you can get from the different forms. The one thing that you can get from all three forms is going to be the concavity. Everything else, you can get all that information from any of the three forms, but you can get some of them from one form easier than others. Now, to make sure we're clear on identifying concavity, this parabola, is that concave up or concave down? Concave up. If it is opening up, it is considered concave up. it's opening down, then it is concave down. Now, what would make a parabola go from the first one to doing that? Think about the absolute value transformations we talked about. Okay, so that is a reflection, and what in the equation, what makes it reflect? The negative. So your first one, that would be a positive a value. That would be a negative a value. So in all three forms, if you look at the top, they all begin with a. So you would just look there and positive concave up, negative concave down. The other piece of information that's easy to get from from certain forms, your standard form, this is going to be the y-intercept. And it is going to be 0, c. Whatever the number is at the very end of the equation, that's your y-intercept. The factored form. On this, you're going to get your x-intercepts, or roots, or zeros, or solution. It's all the same thing. For some reason, those have multiple names. That is going to be the opposite of R1, R sub 1, comma 0, opposite R sub 2, comma 0. So like in factored form, you don't have to write this down, it's just a quick example. If you had x plus 3 and x minus 7, that on the graph you would graph negative 3 and positive 7. Which we'll kind of look at some examples of all that here in just a second. The next one, this is kind of a toughie here. So the vertex form probably gives you what piece of information? The vertex. Next to vertex form, also in parentheses, I want you to put transformations, because this is the form where we'll have our transformations in. And the way you found the vertex for absolute value is the exact way you're going to find it for quadratics. It's going to be the opposite of h, comma k. It's the left and right and the up and down transformation. And again, if you didn't write the all forms up there, if you want to here, you can put concavity. You can get that from all three forms. We're going to skip through this for sake of time. Looking at the standard form. Greta, what three graphs, tell me the letters of the graphs did y'all put for the standard form? A, C, and D. Does everybody agree with that? Okay. So let's talk about what we can find again from the standard form. Your concavity, that's going to be pretty easy. If you got a positive A value, it is going to be concave up. If it is a negative A value, it is going to be concave down. The easiest thing other than that, to get from the standard form is going to be that y-intercept, which is just going to be 0, c. So an example of that is if you look at the equations A, C, and D. Equation A, you got 6.4, so your y-intercept would be 0, 6.4. For equation C, it would be 0, 21. For D, it'd be 0, -1. So whatever that number is at the very end, that is your y-intercept. If you have this in standard form for your axis of symmetry, there's a small formula for that, and that is negative b over 2a. And that's just referencing the coefficients of the first two terms, and then your constant. Okay, in that form, you've got A, B, and C. So to find that axis of symmetry, you would do that. Now, the axis of symmetry, just like it was in absolute value, the axis of symmetry is also the what? Do what? No. What were you saying, David?
Middle point?
Kind of. You're kind of getting there. What is that middle point called? What middle point are you referring to? Okay. So the axis of symmetry is always the what of the vertex? It's the what? The x value. So your axis of symmetry, if you find that, you also have the x value of your vertex. So to find your vertex, you would plug, and I'm just going to put axis of symmetry, AOS, because that's what you're putting in there for. Plug axis of symmetry in for x. And then solve for y. For your x-intercept, you're going to plug 0 in for y. And solve for x. Now, whenever you solve for x, there's a couple different ways we're going to do this. We'll talk about one way today. And that first way is factoring. And then the second way that you can do this is the quadratic formula. Whenever you get all that written down, go ahead and turn to the next page. I think it's the factored form. So Jeremiah, on the factored form, what three graphs did y'all two put up there? F, B, and E. Does everybody agree with that? So the factored form, the easiest thing to find on this is going to be your x-intercept. Alright, at the beginning I told you it's the opposite of r sub 1, comma 0, and the opposite of r sub 2, comma 0. Now if you look at equation F, you've got 2 times x plus 1 times x plus 5. So whenever I say the opposite, if that's positive 1 on the graph, you would graph negative 1, comma 0. And you would graph negative 5, comma 0. But that's what I mean whenever I say opposite those. To find the concavity, it is the exact same as standard forms. If it's positive, it's concave up. If it's negative, it's concave down. For your axis of symmetry, this also has a little formula on it. You're going to take the roots that you actually graph. So that's why I'm gonna go ahead and put the negatives on there. So whatever is actually on the graph, you're going to find the average of those two. You're going to find what is right in the middle. So if I had negative 1 and I had negative 5, negative 1 plus negative 5 is negative 6. Negative 6 divided by 2 is negative 3. And so that would be my axis of symmetry. For the vertex, same thing for standard. Plug axis of symmetry in for x, solve for y. For your y-intercept, you would plug 0 in for x and solve for y. David, what were the three graphs y'all put in there?
With the G, H, and I.
Alright, hopefully everybody got those. So, for your vertex form, again, this is pretty easy. You've got negative h comma k. And now again, if you have the vertex, that means you also have the what? The axis of symmetry. So that's just going to be x equals negative h. Your concavity, exact same. Then for your x-intercepts, again, you will plug 0 in for y. Then solve for x. Again, by using either factoring, quadratic formula. Your y-intercept, you will plug 0 in for x, solve for y. Whenever you have that written down, get your notes packet out that you, or sorry, we got a few other problems on here. I apologize. Yes, but these are very quick. So now going to this page right here. So all this is just identifying the characteristics of the graph that's given and then seeing which equations could possibly give me that graph. So looking at that, Dalton, is that parabola, is that concave up or concave down?
I think it's concave.
Which way is it opening?
Oh, it's opening down.
So concave down. Daniel, is the roots on this, are they positive, negative, or one of each? Negative roots. Meredith, which quadrant is the vertex in? The vertex.
Oh, the vertex?
Okay. And Andrew's the y-intercept, is it going to be positive or a negative y-intercept? Negative. So once we have this, we're going to go through these, see which one, and it's not just one, there could be more than one, equations that could fit this graph. This first one, could this be an equation that gives me that? Yes, why? Because it's, do what? Okay, because you've got negative, so you know it goes down. What are the roots that this equation is going to give me? -1, -4. So yes, this one could work. Probably an easy way to mark off some choices. If it's concave down or if it reflected across the x-axis, which equations can I easily mark off? All the ones that are what?
Positive.
All the ones that are positive. So you got the third one. That's definitely not going to be it. The fourth, the fifth. Then the rest of them are all negative. So this one right here, it's in standard form, so I'm thinking concavity and y-intercept. Is this one going to be concave up or concave down? Concave down. Does it have a positive or a negative y-intercept?
Negative.
Negative. So could this equation give me a graph that looks like that? Yes. The sixth one right here. Is this one concave up or concave down? Concave down. Where, if these two things give me my vertex, which quadrant would it be in? The first one. It would go right 6, up 3. So could this equation give me that graph? No. And all these are going to be concave down because we did that. Could this equation give me that graph?
No.
Why?
Because one of the x values are positive.
Because one of the x-intercepts, that x minus 3, that's going to end up giving me a positive 3. The last one, could that equation give me that graph? Is it concave up or down? Down. Which quadrant is that vertex going to be in? If it's plus 6, which direction is that going to go? Left 6. What about this one? Up 3. So left 6, up 3. Okay. So could that equation give me that graph? Yes, absolutely. So you got 2 more of these kind of problems. I want you to go to the back. I'll be behind you a little bit. I want you talking about these with the people you're around, trying to figure this out.
It's just 6 and 8.
A lot of people, I know in my classes yesterday, they didn't get the first one. But I've got a positive a value, so that makes it concave up. I'm also looking at the vertex because it's vertex form. This is going to give me a vertex of 75, -92, which is going to be in that fourth quadrant. So that one also would work. Okay, so those are the 2 things that vertex form is going to give me. It's concavity and the vertex.
It's got a positive concave, a positive y-intercept, a vertex in the first quadrant, but it doesn't have any roots.
Okay, so make sure that you are on this page right here. So this first problem, or both of these, this whole top box, it's going from factored form to standard form. Does anybody know what the method is called whenever I multiply two binomials together? It's what you wrap your baked potato in. It's a nice little acronym, FOIL. Okay? Does anybody know what FOIL stands for? First, outside, inside, last. So first, I'm going to multiply the first two terms together from each binomial. That's going to give me 2x squared. Then I've got x times negative 1, which is negative x. Negative 2 times 2x, which is negative 4x. And then the last term from each, which is going to give me positive 2. I would then need to combine my two middle terms. And that's how you do FOIL. Now, you may have been taught a different way. You may have been taught to do it like this. Probably just depends on who your teacher was. If you were taught to do it like this, awesome. Do it like this. Okay, if you feel safer doing it like this and you're more comfortable with it, awesome. But you need to know that whenever I do this, whenever I say, hey, multiply these using FOIL, I'm going to do it this way. You just translate FOIL to box in your head and you can do it that way. Okay. Next, we're looking at vertex form and we're going to go to standard form. This is extremely similar to what we just did. So, if I've got x minus 2 squared plus 1, let me back up. If I have x minus 2 squared, how many x minus 2's do I have? 2. So, I'm going to write out both of those. If you ever hear me say expand the exponent, that's what I mean. Once you have that expanded, what I did on that first problem, I'm going to do with those two right there that I have in the red rectangle. FOIL, box, whatever. So whenever I do that, I end up with x squared minus 2x minus 2x plus 4. The biggest mistake people make on these is they get so caught up in doing FOIL or box on that part of it that they forget about the plus 1 at the very end. You cannot forget that. And then I would just combine my like terms. X squared minus 4x plus 5. Going down here to the bottom. So on this, the main focus on this is going from standard to factored form. And we're going to do this by factoring. So, I've got x squared minus 2x minus 8. Now, you were you were taught to factor in Algebra 1. The way you were most likely taught was, it was the box method again, and then you put the first term there and the second term there. And then you would have to find the factors of negative 8 that equal to negative 2. And you put those there. And it's just a very long process. Very drawn out. I'm going to show you a different way to do it that I think is a little bit quicker. And I feel like there's less opportunities to make a mistake. So how I factor these is I'm going to multiply my A term times my C term. And you'll always see me draw that little triangle or pyramid, whatever you want to call it there. Make sure you know that coefficient of x squared is 1. So 1 times negative 8 is what? Negative 8. Then I need to find the factors of negative 8 that add up to negative 2, which would be what? Make sure your signs are correct. No. Negative 4 and what? Negative 4 and positive 2. All right, know what we're looking for here, guys. They're factors, so they would multiply to give me the negative 8, and they would add up to give me negative 2. So the numbers I'm looking for is negative 4 and positive 2. So whenever I have that, I can go ahead and set up the factored form, and I'll put plus or minus a number after each x. And whatever those factors were that I just found, that's what goes in there. Negative 4, positive 2, and I'm done. Alright? Alright, let's talk about that. So, coming over here, first, standard equation. What piece of information does that give us? The y-intercept. What is the y-intercept in this equation? Negative 8. At the very, very end. So I can graph that. Now, whenever those signs flip, it's from the equation to the graph. So x minus 4 is going to give me what x-intercept? Positive 4. X plus 2 is going to give me what intercept? Negative 2. What I would probably do is I would find the axis of symmetry by finding the point that is right in the middle of these two. Okay, so it's 1, 2, 3, 4, 5, 6. 6 divided by 2 is 3. So I would have my axis of symmetry at x equals 1. Anytime you have one point on one side of the axis of symmetry, the point that is symmetric to it will give you another point. And to find what the y value of my vertex is, I would just plug my axis of symmetry into the equation. So that's going to be 1 minus 2 minus 8, which is negative 9. So now you have all that information. You can easily graph that parabola. Going down to this one, all I want us to do on this one is to factor it. So, I've got negative 15 there. What factors of negative 15 add up to positive 2? 5, so positive 5, negative 3, it's factored.